Okay, so this is going to be an explanation of visualizing probabilities with Venn diagrams. So here's the first one, right here. And here on the right is the Venn diagram associated with the problem. So you notice here's the probabilities. Probability of A, 0.2, probability of B, 0.3, probability of A and B is 0.05. Now you notice these are not independent because if they were independent, then 0.2 times 0.3 would equal probability of A and B, but it does not. You'll also notice that they're not mutually exclusive because the probability of A and B would be 0. So they're composite. All right, so first problem is find the probability of A and not B. So for that, it's going to be probability of A minus the intersection of probability in A and B, which is 0.05. We want the probability of A, the circle on the left, minus the intersection, this little section in the middle where they overlap. So 0.2 is probability of A, 0.05 is a probability of A and B. You subtract those two and you get 0.15. That's the probability of A and not B. All right, next example. Find probability of not A and B. Well, that's going to be similar to this one. It's right here on this Venn diagram. That's what it looks like. Probability of B minus the intersection. So you'll see probability of B minus the probability of A and B, the intersection. So probability of B is 0.3. You can see right here, I rewrote it right there, minus the intersection, probability of A and B, 0.05, and you get 0.25. Now the next one is find probability of A or B. So let's do probability of A is 0.2, probability of B, 0.3, minus probability of A and B, because that's where they overlap. And you can see right here, if you think about it, your probability of A is the circle on the left, probability of B is the circle on the right. If you just those two have an overlapping section, that's why you have to subtract probability of A and B, that intersection, so you don't count it twice. And you get 0.45. All right, so let's move on to another problem. Another example. So probability of A equals 0.3, probability of B equals 0.4, probability of A or B equals 0.6. So we got to find the probability of A and B based off what we're given here. So probability of A or B, we know that's given. We know that's equal to the probability of A plus the probability of B minus the intersection, probability of A and B. Well, we can do some algebra here, some Boolean algebra, some probability algebra, and what we can do is we'll add probability of A and B to both sides, so it would delete this one from this side of the equals sign and move it over here to the left side of the equal sign, right there. So we added that to both sides of the equation, and then we're going to subtract probability of A or B from both sides of the equation. So we get rid of the one on the left and we add it to the one to the right side of the equation. So that's how it's rewritten. Probability of A and B equals probability of A plus probability of B minus probability of A or B. Now we just got to plug and chug. So probability of A is 0.3, probability of B is 0.4, and then probability of A or B is 0.6. So 0.3 plus 0.4 minus 0.6 is 0.1, and that's how we solve for probability of A and B. All right, another one right here. So find probability of A and not B. So we're given probability of B, and we're given probability of A or B. These are just repeated from right here. So probability of A and not B is equal to probability of A or B minus the probability of B. So you can see that visualized right here. Probability of A and not B. So you subtract the intersection of A and B. And you can see that is written probability of A and not B equals probability of A or B minus probability of B. So it's basically rewriting it a different way. It's slightly different than how we did it. So probability of A or B is basically both these circles, everything inside these two circles, minus the probability of B is what's inside the circle of B. And that gives you the same thing, probability of A and not B. So probability of A or B is 0.6, which we got, that was given with the problem, minus probability of B, which is 0.4, given with the problem, and that gives us 0.2. You got to find probability of not A and B. So probability of not A and B, that's equal to probability of B minus the probability of A and B. And you can see that visualized right here with this Venn diagram. Probability of B minus the intersection, the center part. So probability of B is 0.4, which was given. Probability of A and B is 0.1, which we figured out right here in this earlier problem. And 0.4 minus 0.1 is 0.3.